Hello, everybody. Today is the 15th of August. Dallas Person Robotics Group, Robot Builders Night online, virtual. We get out as we can. Do our usual routine tonight and bounce around the table, talk about updates on our robots and related projects. The queue tonight is Ray, Mike W, Doug P, and then open mic. So, Ray, it's all yours. Take it away.
Okay. Okay, let's see here if I can get this up. Okay, I was repairing my alarm system and bought this board. It's got an ESP 32 on it. There's a power management device. There's a SIM 7080G, which covers Category M and narrowband IoT. This also had a battery charger on it and even a battery holder in the back of it. So it was kind of a nice setup. Kind of fumbled around like you kind of do initially when you're trying to get something running, and got it running. I could make text, send and receive text. And then the processor just stopped communicating. I couldn't load up any other code to it. So I've sent it back to LilyGo, and hopefully they're going to send me another one. I'm not certain what happened. I don't know if it was, which part failed. It's mostly surface mount parts, and I don't have any way to, to diagnose it or repair it. So it's kind of nice that all this stuff was integrated in this package, but not so nice when it breaks, because then, if you can't repair it, the thing's pretty much useless. So I've decided to go to I want to use the same module, the SIM 7080G, but I'm going to do it with, and there's a couple boards. Let's see, this one I'm hoping to get a sample on. I contacted andglobal.com, and they're going to tell me if they're going to sample me something or not. There's another one that's similar. This one, it's a little bit smaller. It brings out more of the control pins. Like if you want to do a low power application, you can actually turn off. Let's see, that should say GNSS power enable, but I guess they omitted an S. So that, you can put it basically in a low power mode or lower power mode if you have that option, versus just turning everything on, or only some things. So I'm still going to go with stop presenting. Still going to go with the ESP32. And I've had one of these for a long time. It's a port expander, MCP 23017. Let's see if I can tilt this up without dumping everything out, or tilt it down. Anyway, so in the rat's nest there, that's an ESP32. That's the MCP 23017 port expander. I was going to add a small OLED display, so I can fix things easier. And I guess the other thing that I was going to do is put it, so it's all on one board. I had actually either an Uno or a Mega as part of, there was, an Uno was in the garage, and I had a serial line between the two buildings, and 9600, and it was working fine. Anyway, on both of those boards, I had a proto board that stacks on top. And that's kind of nice because you get the pin connections, but not so nice when you have to tear it apart, or if you want to look at signals on the board that's underneath, because it's just hard to get to. So I think I kind of like the, it's the goldfish bowl approach. The alarm system had a box of a certain size, and I'm going to make use of all the space in the box so I can get in there and replace modules if I need to, and that kind of stuff. So, I was, a little disappointed. I'm getting code going and doing things that I wanted to do with the module, and all of a sudden can't write to it anymore. It's like, ugh. So anyway, it was reasonably priced. Hopefully the next one isn't going to crap out so soon. I was in the, Amazon, they have like a 30-day return policy. And so I was in the 30 days and, sent it back. So I guess that's kind of a thing of design, lots of integration is great, but, if one thing on that thing breaks and you don't have the capability of replacing it, then it's not very good. So, that was another thing I was going to do. Instead of the serial line coming from the garage to the house, it's just on, like twisted pair phone lines. And 9600 baud, it was fine. But I think lightning hit the metal building, and it either shorted to like a little LED indicator that I had to show that the thing was either on or off, or it induced a voltage in it. And, it fried an Uno, and it actually popped I don't know if you can see it, it's pretty subtle. Whoops. There's a little hole on the top of the Mega right there where I guess some high voltage got to it, and basically, there you can see it a little bit. Blew off the top of the, part of the top of the IC. So,
that's pretty impressive to punch a hole in the, and it's interesting that it punched a hole in the middle at the top. It didn't do it at one of the seams.
Oh, at the edge, like a pin? Yeah. I guess, yeah. Whatever was, whatever part of the chip exploded, basically. I guess couldn't take the, the voltage or current or whatever, but, so yeah, it's been, it's like, what other things could I do? So I was going to stick, an optocoupler in serial line, and that'll give me like, I think at least 5,000 volts of, surge protection, and isolate, one side from the other. So maybe I'll just blow out, the stuff in the garage, but not the stuff in the house and the garage,
Mm-hmm.
So,
you could also put, let me think, what do they call them? There's a little, it looks like a small ceramic capacitor.
Oh, MOV, metal oxide
put
varistor.
some MOVs, on there.
Yep.
And that might give you a little help too.
Yep.
And chances are you got a gazillion of those around, because if you have a dead LED light bulb, you probably got one. So.
Oh, really?
Yeah, I believe so.
Didn't know.
Yeah, depending on how costed out they are. If you have one that's a fluorescent, for sure you got one.
Oh, really? Huh.
Yeah, one of those old-fashioned ones.
Yeah, huh.
But what's the nature of the signal? Are you trying to send more of a voltage level signal or one that's a current level? Like a high impedance or a low impedance?
Yeah, it's just a voltage level, and whatever the RX port impedance is,
So the direct input to the RX on the Uno?
Yeah, it's going basically, TX to RX, transmitting from the garage, receiving in the house. If there were any, basically open doors or open windows. So it sends just a switch code. It's just a byte saying.
Yeah, but it's a voltage. I mean, it's basically toggling a voltage. So I think from what I recall from the days I was more active in this, you're in a way fighting a losing battle because the voltage range on the semiconductors is so close to 5 volts, the rail, right?
Yeah.
And you don't have to get that much above before things fry. And it's a high impedance. So it doesn't take that much of an induced current to go cause problems on the chip. So one thing I would suggest is, I haven't looked for these in a very long time, but I think you should be able to find, and I'm sure you could do it with an op amp pretty easily if you dusted off all that high-tech op amp math somewhere. Yeah. But what you want to do is what I think you want to do is change the not only the source to a low impedance, but also the receiver end to a low impedance, so that in a way you're toggling like the difference between a small positive current and a small negative current, but the impedance, keep it down in the tens or hundreds of ohms instead of the megohms like you have with the input for a logic input on a chip. And I think if you do that, then all these other measures like the little RF chokes and the MOVs, they'll help, but fundamentally it's a lower impedance, so it's going to be much harder to induce a problematic voltage that breaks down the dielectrics. So differential, I think I would look at current, I think it's called current drive or differential logic current driver or something like that. But
yeah.
Current loop.
Yeah, current loops. I think it's, God, I want to say EIA something.
Well, it used to be like RS 485, I think it was.
Yeah.
485. And I think the original RS 232, I think part of that, if I remember right, it included a current level drive, so you could go longer distances.
Yeah.
For just that thing, because otherwise it's so easy to induce a significant, when your logic threshold is like 1.7 volts, a little above and below, it doesn't take much to induce a voltage that triggers the wrong thing.
Right.
But if you're pushing a couple milliamps of current, it's a lot harder to induce that much current for a long enough time that it makes a difference in the logic.
So, Carl, if I follow you, what you're saying is just use one of the standard, what is it, 20 milliamp low loop type communications.
Yeah, there's got to be a breakout board for that.
I'm sure there is.
Maybe some of us can search for that here.
Yeah.
Anyway, so yeah, I guess I got to rad harden my alarm system, to make it survive.
Yeah, well, that's one of the problems out in the country. You get hit with lightning a lot more.
Yeah. Yeah, I haven't found, if it did strike. My neighbor said they saw sparks coming out of the building. So, but there's no leaks, and I don't see any burn marks or anything. So maybe it hit somewhere on the ceiling or the roof rather.
My wife's parents lived out in the country, and every so often things would just stop working. The television would, and they'd just have to get a new one, because they get hit with something.
Yeah, we get, it seems like it interferes with, AC power distribution too. We get a lightning storm and the power will flicker, and you kind of wonder, wasn't like did a line get hit and, that super high voltage is just, zinging through the system and.
Usually when your voltage flickers, it's a lightning arrestor that's shorting to ground on one of the phases.
Yeah.
Yeah, I'm assuming
when that happens a lot, you'll see a boost on the other voltage, the other phase. So one phase will go to ground, the other one will go up a little bit.
Huh. So, yeah, but I thought they wanted them pretty balanced, right?
They do, but they can't control lightning.
Yeah, yep. Yeah, I actually saw a transformer that got hit by lightning. It looked like a bomb went off in the thing. It was like, you could kind of tell it was the case of a transformer, but it was just like spread out, and I don't know. It almost looked like, someone artistically, took a torch to it or a plasma torch or something and cut ragged edges all over it, Yeah. So.
Or the ones I've seen, they look kind of like, how a can, when it goes bad, how it swells up. They look like that.
Oh, they puff up? Yeah.
They puff up.
I took apart a 13,000 12.47 kV transformer on the primary dry core transformer. We were cleaning it out. And on the copper bus, the primary was like 3/8 of an inch rod copper bus. And there was pitting on it. And then on the casing that was a foot away, metal casing, there was scorch marks. So we know that the line coming into the building got hit by lightning, and it arced. It was over a foot. So that was a lot.
Oh, it was a foot that it arced? Yeah. Oh, yeah.
It arced over a foot, and we did have lightning arresters on the line.
Huh.
So here's a fun fact that I learned when I worked on 20,000 volt gas lasers for the military. In normal sea level and humidity air, it's basically 20,000 volts per inch to draw a spark. So think about that when you drag your feet on the carpet and you draw a spark to the doorknob. It's 20,000 volts per inch. And if you're talking about a foot there, Pat.
Yeah. I was surprised because, you're looking and it's arced, that far, more than that far away. And you can clearly see it on the side of the transformer casing, the metal painted casing inside. And because they're coming off insulators and dropping down to the coils in the transformer. And these are big coils. They're huge.
Yeah.
It's, and it was, 1,000 MVA transformer. And it's arc. So, yeah.
Big stuff.
A few volts there.
Okay, I just put a link in. Just a quick search on Amazon shows what might work for you.
Yeah.
Right?
Well, thank you.
And there's some others like that too. Like here's 4 of them for $12.50. So that was just searching for current loop to TTL converter, something like that.
Yep. Okay.
I'd highly recommend that though.
Yeah, I think 485s, I think they were used, well, I know they were used in one of the assembly division plants at General Motors that, they would string wires for, thousands of feet and go all over the plant to monitor equipment and
Oh yeah.
stuff like that. So
RS-485, yeah, it's used on the old PLC networks.
Yeah.
So Data Highway Plus and Remote I/O was all based off of it. And it's still going strong. It's slower than anything, but it's still, it was very durable.
Here, RS-422 to TTL UART module. It's a little more expensive, but yeah, I first hit this. I stumbled on this where I made one of my first serious projects at TI Defense World was to make a test set for somebody else's ASIC, which I later showed couldn't run fast enough to keep up with the speed of light. But this test set, it had to have a safety interlock with the chamber. like an environmental temp chamber, because if you open the chamber, you didn't want the lasers to blast somebody's eyes out, or something like, or yeah. So then there was a feed through, so it was counting events or something, and what happened is that they were getting really strange data, like an impossible number of output counts for an event that shouldn't happen that often, and it took a couple days or a couple weeks, and it finally got tracked down to, like, every time they would open and close the door to the chamber, that would throw an impulse on the switch, because it had like a 30-foot cable to the board I was doing, and I was just using a voltage signal, and just the fact of closing that switch with whatever pull-up resistor I had, simple-minded me, it was enough to throw a spike that caused a false trigger at the logic board. Just stupid stuff like that. So, damn, the real world is just such a pain to deal with, isn't it?
Yep. Got to do things slow and current loops, and
little bits of radiation from now and then from the sky, flipping bits and voting machines. Well, Ray, that's a cool update. We look forward to
Is that the defense?
What's that?
Is that the defense? Little bits of stray electricity or radiation going through the air, flipping bits?
I was hearing or reading an article once where that was actually documented. So they were tracing down this one place that had reported like 1,024 more votes than were possible to be recorded from that district. And the person looked at it and said, 1,024, that's a rather specific number to be wrong by. So they actually went down and traced it back to an errant bit flip somewhere in the machine. And they were able to document and prove it. So
interesting. They're only out by one, but in the 1024 position.
Yeah, it's
right.
one stupid little bit somewhere, right? And then you start to realize, so that's why they have these things like error correcting memory for servers. And
so what happens when we get to 2 nanometer circuitry?
it's just got to be more resilient, right? That much more in the redundant architectures and the error detection and correction. I think it's just Hamming codes out the wazoo or something like that.
Yeah.
The other thing that got me was that, so I laid out circuit cards in the 33 megahertz days, right? And you had to take care of things even then, and inside the chips themselves. But I learned quickly that, as I was finishing up my last FPGA to run at speed, at the max speed of like 30 or 40 megahertz, the early Pentiums were starting to come out, and they were like 200 megahertz. And before long, you have the gigahertz ones, the 2 gigahertz ones. And that's when all of a sudden I started to read that, at that point, the wavelength of the frequency and the wavelength and the distances on the large processor chips were such that to get clocks and other signals distributed across the chip, you had to treat it as an RF transmission line, or else you would have reflections and backscatter from a signal on one end of the chip you're trying to send to the other. It's like, and then you read on further that like on the clocks, if they would keep the if I understand it right, if they would just run it strictly at the fixed clock rate, so the PLL goes up to your 2 gigahertz processor and it doesn't vary much, then it would throw spurs all over the place because you'd have this nice precise 2 gigahertz hitting all the time. So what they actually do is somehow magically in there, I think, is that they muck with the PLL or something. So they actually dither the clock rate around a little bit so that they reduce the emissions of the primary switching rate of the processor. Let's just say there's some crazy stuff going on inside the ridiculous things in our phones these days. I mean, it's crazy. And, I mean, the processors, right, they're running at the same speed as the internal buried antenna that's hitting the cell towers. and they're working together coherently. So it's just magic. I mean,
Yeah. Well, they take their clock speed and they dither it.
yeah, that's what I'm saying. They speed it up and slow it down. They bounce it around to randomize it. So instead of having one giant spike, they have a little bit of a lower, wider spike in the frequency spectrum. But anyhow, again,
that's why my door lock won't turn around 180 degrees.
There you go. It's the RF bit slip. It's here. Well, Ray, are you done? Shall we pass the baton to Mike?
Yep.
Mike, what you got?
Well, I'm waiting for my OpenMV camera. I ordered the latest one, and it's supposed to be in production and shipped sometime soon. I'm not sure how to follow up on it and see when it's actually coming. I think you just have to wait. I've never dealt with them before, but like pre-ordering. So that's my robotic thing, is waiting. So I figured before I do a robotic project, I need to master some visual sensors a little better, so that I can make one that works. And so in the meantime, I've been working on this project that controls the smart bulbs from a DMX signal, which is a professional lighting control console signal. And I've decided to redo everything. There's nothing to say. And it seems like I needed to use the what do you call it? Well, let's see, ESP IDF inside of Visual Studio Code, because that's where the libraries for the smart bulbs that I wanted to use for that protocol. And so I've been beating up myself on ESP IDF, because it's really complicated the way they set up their support structure. But I've gotten lots of stuff to run. I've gotten the DMX decoder in a Raspberry Pi Nano, Pico in the PIO, and sending it over using I2C to the ESP32. So it seems to have enough bandwidth to do what I need and more. So I like the I2C. But now, well, I decided I didn't want to use a LCD touchscreen. So I said, I'll just use a web page. Like on a phone or a pad or something. Because it's just for configuration. It's not even used when it's running. It's just to configure it. And so now I'm learning all those ins and outs. Like I've avoided learning HTML and styling and CSS and JavaScript. So now I'm have to learn it all, and then how to send get and put between the HTML and the Java code and the ESP32 over Wi-Fi. So and that uses JSON. So I'm trying to understand JSON a little more and the tools. So they got tools in C and they got tools in JSON script or JavaScript. So they're able to talk to each other. So now I have a file for the configuration that's in the flash of the ESP32, and it's accessed as a file, which is the way the web pages are stored, and they get accessed as a file and sent over to the browser. And so I just learned how to open and close that file, open and read it, and then turn it into actual JSON object and send it across to the browser. So I'm learning a lot. I'll see if I can show you my setup. There it is, sort of. It's hard to see, but it's a bad angle. But like this is the ESP32, and this is the Raspberry Pico, and over here is my original prototype, right over here, and I got a wire sending over the DMX signal from the prototype to this board so it can decode it. And I got scope probes on it to try to look at the signals. So you can sort of see it. And what I'm finding out, well, I'm having a hard time debugging the signal to try to understand what's going on. Because it works most of the time, but sometimes it has a bad frame error, but it's pretty redundant, so you can, yeah. So for a DMX frame gets lost, it's still fine. But my scope I have is really primitive triggering. It only does like edge triggering. And so I ordered a FPGA with an Arduino in it, so that I said, oh, I'm going to build my own triggering circuit. But you really need logic, FPGA logic to do it. So it's a project that I haven't even taken out of the box yet. I bought the FPGA and I know how to do Verilog, so it won't be new. It's just the environment that'll be new. So hopefully I'll get a trigger in there so I can debug the DMX decoder a little better. So that's what I'm doing.
So, Mike, I got at least 3 questions for you now.
Okay.
So the first is, have you discovered a tool called Postman?
Yeah, I figured that'd be good for debugging. So.
Okay. Yeah, I mean, because for sending gets and puts and JSON bodies, I mean, it's a really handy way to send commands to one part of your system without having to have the other part working.
Right. Yeah, I've heard about it and I've seen it. I've never put it together. I'm using like the fetch command in JavaScript to do the fetching, and that's pretty complicated. It's asynchronous code, and oh no, that's sorry. I think fetch is in the C code. Okay, so I'm getting confused over C code and JavaScript.
And that was the next
Okay.
question: is if you've gotten to the whole synchronous, asynchronous concepts behind JavaScript and the way the event loop runs.
I'm becoming aware that it exists, and I'm learning, and I'm appreciating it, or well, I don't know if I'm appreciating, but I'm knowing how to manage it. So
Okay, so you're finding your way through it. I might have some resources for you.
Doesn't this work? And I do a little Googling. It's like, oh, that's why it doesn't.
Okay. I might be able to help you if you get stuck, because I taught enough to be dangerous to myself some years back in JavaScript, but changing the mindset from a functional language like C to the event-oriented asynchronous language like JavaScript is it's an interesting journey.
Yeah, especially when the two languages or the text of the two languages look the same.
It looks very similar in a lot of ways, and also
Right.
JavaScript is shall we say, not quite so strict about types.
Oh, oh yeah.
And this whole concept of a Boolean, right, is truthy or falsy. So, like, if it,
Right.
depending on, it's.
And I haven't found any good debugging tools on it, or I haven't really searched them out. But yeah, so let me see if I can do something. Let me do a share. Here, window. Here it is. Yeah, so this is a this is basically my of something that has like 10 fixtures on it, represented by buttons. And then here's like the debugging in the browser. There's probably some plugins that can do more. I just haven't really gone down that road yet. So I'm trying to understand how to use the debugging. It's helped a lot. Like, why isn't anything working? And that's why I popped this up. Like, okay, there's a few errors. And like this one here, I cannot figure out why it's sending this icon across. I can't find it anywhere in the code that's asking for it, but it's just happening automatically. I don't understand. And I even have it available, and it still gives me this error. I'm not using it. And so so if I press a button on here, this is like this is fixture 4. So I want to configure it, and it'll bring up another thing where I can then select the type of fixture it is and change its brightness and its red and green and blue levels, and change its starting address and everything. So
nice. So the fave icon is the fave icon. If you look at those tabs, the fave icon is what's like on the others. It's on the left in front of the words on the browser tab at the top.
Yeah, but there's supposed to be that one there, that red one for ESPI. Yeah, but I don't see it on mine.
It's not showing up on yours.
But it's
the other thing is,
this is successful. Wow. Okay. Go ahead. Yeah.
If you check on, so you have the console selected now. If you go over to the network, have you ever looked there?
No.
This is really useful. So what you can do here is, okay, this is a different browser. I'm used to Chrome or Edge. But if you go down below network over a little to the right, you see where it has the circle with the line through it? I think if you click that, below that, above that, up, where it says filter URLs, then go right past the pause plus search. Go right.
Oh, okay, right here.
Disable cache.
Click that.
Request blocking.
Okay. That's not what I expected it to do. So click that again. Damn it. Okay. On the far left here, there's the trash button. What happens if you hit the trash button left of a filter URL? Okay. So now if you reload that page on the top, So that shows you in sequence, and you can see the waterfall timing over on the right. It shows you what it does in sequence, and that'll give you insight as to what's happening in the order that it's happening and how and when.
Mm-hmm. Because this page is reaching out to the server and getting the fixture number. Yeah, I just needed to get the fixture number, but now I'm upgrading it to get all the information about the fixture, which is in the JSON database, which is in the Flash.
Yeah.
So I can configure it and then save it off.
But see, you can even click on one of those rows, and it'll show you the contents of the fetches. So if you click on one,
here's where it's getting it.
Yeah, and it's 134 milliseconds.
Wow, just to get that number.
Yep. So I've been shocked when I watch the pros at my work. When I watch the pros who know how to use these debuggers get to it, they'll go in and using this tool or whatever browser they're using, but it's a similar tool. They'll go in and they'll modify, they'll check the state of internal variables on the page. They'll go modify the code on the page. So without changing the source code on the device or the server, they'll go modify it in the browser and check their stuff out. So there's some really capable stuff in here if you know how to drive it, but it's so powerful. There's quite a learning curve.
Yeah.
Right now it looks like those are just gets and puts. 500. Wow. So fave icon says it's no response. It's giving you a 500. And if you click on the initiator of the blue text and that over the right, with the pink, yeah, that column that says initiator, go over to the right. Over to the right, left and down.
Oh, here it is. Okay.
That one or that, well, that's your long one. And look at that 2.5 second reply. But down right below that, it says fave icon load. If you click on
So
that,
kind
we'll
of
see.
Okay.
And then, oh, there it is down below.
Uh-oh, what did I do?
Oh yeah, you clicked on it and it's showing from where, yeah, so the first one says resource loader. It's in that service line 176, column 20. And then the one below it is line 563, column 70. So, but if you go even down further below, you'll see in the red, way down at the bottom of the screen, it tells you more about that internal server error. So,
Oh, right.
yeah.
Yeah. Wow, 2.5 seconds. I noticed something was slow. I'm not sure where that speed is coming from. Sometimes it's fast and sometimes it's slow.
Yeah.
How do I get back to that network?
Console. You were on console before, which is a good place to check for not network, but left 2 is console.
I clicked on that favicon thing and I'm trying to figure out how to get back. What changed?
You mean to get?
Like this used to be like the time. Oh, maybe it's this. No.
Oh, the water. I would just
I see.
reload it.
Well, this is just looking at this. How do I look at them all again? Uh-oh.
I don't know. I'd clear it and reload it. It just takes a lot of fiddlery. I know the Chrome one better.
Oh.
There you go. But
Yeah.
before,
Well, it's numbered all over the place, so I'm wondering if it's the ESP32 or if it's something else. I don't know. But it's able to get like the fixed. It's able to get like the files over pretty fast, but the
lookup
fetch command is to send this to the numbers slow. Yeah. Oh, look, the favicon showed up.
Oh, how about that? Huh. Maybe it's just some kind of timing issue.
I don't know. All right. So let me get out of this.
The only other one that I was going to ask is that you got this FPGA to do your debugging. So
Yeah, to get me a scope here. Yeah.
did you look at that one open source? There's like an open source project that can use a bunch of different logic analyzers. And that open source project has built-in protocol tools. So you can download I2C and I don't know what else, and it'll decode those protocols on your with an open source tool. So you can just read the bus that way. I forget the name of it. I couldn't find it here real fast, but I'll see if I can't find it and share it.
Oh, you're talking. Okay, it's a module that connects.
It's an open source tool that knows how to read protocols. So instead of having to, it sounds like you're going to have to roll your own FPGA Verilog thing to decipher the DMX. I'm wondering if this tool already.
I was just trying to look for electrical signal problems that could be causing something like timing issues.
Yeah.
Yeah. Because it's doing a good job of decoding it, but just sometimes the packet's wrong. It has the wrong packet, or something's wrong with the packet. So, but yeah. So I've always complained about my logic analyzer having crappy triggers, so I got a little project to maybe make it better.
Sounds good.
Yeah. Does anybody know a solution for a nice little trigger module box that you can configure to do different triggering and triggers your scope. It has a crappy, because it's like a cheap scope and it has just 2 inputs and then you can trigger off of a level change on one of the inputs.
Well, Mike, are you using by any chance one of those little saline knockoffs analyzers? Let's give me a second here.
Yeah, so
Yeah, I thought, Carl, you had one too, right?
Yeah.
It is a scope, not the logic analyzer.
Oh, so the scope has
These
can decode.
things
Like,
I think are about
different
$10. Oops.
Yeah,
They're about $10, and you can use either open source software or Saline. I forget what they call it. Something like Input or something, which is really nice, and it has all the analyzers for all the different protocols in it. So, I mean, I got to admit, it's about the best $10 I've ever spent. So, yeah.
okay, yeah, an analyzer would be in addition to a scope.
Well, this will it go. It's USB to your PC, so your
Right.
PC screen is the output. And
Right.
It's very, very useful. Let me see if I can find an example. I'm gonna, yeah. Where am I at? Yeah. Let's see.
Yeah, 'cause like the DMX signal was like 2 megabits per second or something like that.
Yeah.
Or 2 megabaud.
Mega sounds pretty busy. That's a good speed.
Or is it 256? I think it's
That's all.
256
Okay.
bytes. Okay, or that'd be 2 meg. Yeah.
Yeah. Okay. So if you search for Logic Analyzer 8CH or 8 channel, this one will pop. One of these things will pop up for about $12, and I'm trying to think of if they talk to you about where you can get the software, but that uses an FPGA. And there's in there. If you go down their images, you can get a good example of what the output looks like on the 4th picture. Are you? I don't know. Did I?
Oh, I'm looking at just the Google search.
Yeah.
Seeing things that look like what you showed.
Have you found that there's like speed limitations? Can you not do, the super high UART rates, like, 3 megabits per second or something, or with that? I mean, is there,
Well, the little 8 channel thing has got 24 mega samples per second.
Oh, okay. Mm-hmm. So I guess you could do stuff at 12.
Yeah. Yeah. So, I mean, like I say, for $12, and like I say, you have to hunt down the software. I don't know if they mention it, but it's pretty easy to do with a few simple searches. That I would, if you don't have one, I definitely would get one and see if that fits some of your needs, because it's definitely a good deal.
Yeah,
Are you talking about the little one that uses Pulse View software?
I don't know if it uses Pulse View. I'd have to look up Pulse View.
Yeah. I was just looking at one of them and I was wondering, hey, does this have like an output channel that you can program to put a trigger output?
No.
Not seeing that.
Yeah, you can take the channels. If I can find the name of the program, I can probably pull one up. Let's see. Is it Logic? Yeah. Okay. The name of the one that's done by the company that did the original, and you can buy it from the original company too, but they're considerably more expensive. Let's see. So you have the choice of picking let's see if I can get it. Let me start a simulation here. All right, so you can pick the trigger can be either a leading edge, a falling edge. I can't get it to. Okay, trigger a high or a low, or don't care. I'm not sure exactly. I'd actually have to hook it up to something to get an example. But if you hook it up to like I say, it's very easy to use. The logic, the software, let's see if I can find it. Get a download link. See if they still, okay, I got something called Logic 2, so I'm not sure if they've made it, they might have made it harder. Looking for Logic 1, let's see what this is.
I found one for $1,000 too.
Yeah, well, they're much more. Yeah, they have like 32 inputs. You're never going to use more than 8, as a hobbyist.
Yeah. Yeah, but one thing when I had access to nice, complicated, fancy scopes at work,
yeah,
I just never saw a DMX protocol encoder because it's just not common.
Okay, well, like I say, this guy, I don't know if I can get to it on their, see what analyzers, show more analyzers. Okay,
for $7.
So they have I2C, SPI, HIDE, no, wait a minute, that might be just HIDE. One wire, ATMLS, single wire input, B, Bliss, C, CAN, DMX-512. I mean, they got it.
Oh, that's it. DMX 512. Yeah.
Yeah, they got a whole bunch of them. I haven't gone down through all of them. They have JTAG, Lin, MDIO, Manchester, MIDI, Modbus. I mean, they got analyzers for almost simple parallel and everything. It's really pretty nice.
Right. And so my thing is like, okay, it works 99% of the time, and then what's that one that's missing?
Okay, and I would not be surprised since they're not very interested, I think, anymore in these 8-bit ones. I mean, not 8 bits, 8 lead ones, because that's not their market. So I don't know if you can. They've now gone to. Okay, well they do. They still have a legacy 1.240, and it's a Windows zip or a Linux zip, and that'll work on those little cheapy ones.
Yeah. Well, one good thing about me getting the FPGA is, it can really give. If you use an FPGA for the servo drivers on robots and stuff, they're extremely accurate. But so I might have a chance. I like a robotics where I need some high accuracy. Like you can process the what do you call it? The tracking of the wheel.
The encoder.
Encoders?
Yeah.
You can process that really well. That instead of relying on interrupts on the processor and stuff. But,
Dedicated silicon, basically. Yeah.
So it's something good for my toolbox just to learn how to do it, how to get one going. Especially with an Arduino, there's an Arduino core inside the FPGA, or there's a RISC core that they configured for Arduino, and it has the Arduino interface from the IDE to control the processor, and then there's a chunk of logic that you can use that you can configure yourself. So it's a really, really cool FPGA with Arduino mixed together. I'll unpack it
in everything these days, right?
But that's all I have. So
Cool stuff. I think, Doug, we had you next in line.
Okay, give me a second here and find myself again. Okay, I just wanted to update. As you all know, I've been playing around with my little metal router, and so I'm going to share something. All right, so this is what I was able to do with it. So as you go up this axis, this is 0.2, a depth of cut of 0.2 millimeter all the way up to 0.5. And from here to here is 1.25, 125 millimeters per minute, 150 millimeters per minute, 175 millimeters per minute, and 200 millimeters per minute. To go from here to here is a speed increase of about 3x, I guess. This is a little more. And this was a mistake I made. And this is a duplicate of this one because I wanted to check that out again. And anyway, these are nice little pockets. They were cut with a 1.875 millimeter two flute end mill, and this is the end mill. You can see there. You buy them in groups. Well, you buy them in groups of 5, and they cost about $7 a piece. So that was cheaper than the other one that I had last time. Plus, if I broke one, I wouldn't be out of luck to continue my test. So, and those are really good bits. I mean, I've made all of those, and it looks as sharp as when I put the first one in. Did the first one. So, I might buy some more of these in quarter, because I made those pockets that you saw. They're 15 millimeters by 15 millimeters. For this particular tool, they actually go around 3 times. But with a 1/4 inch, they would have gone around twice. So I've got 2 sets of tools now, single flute and double flute that I feel pretty comfortable with. I'm not using any high-speed steel. I'm just going ahead straight to carbide because it lasts so much longer. And anyway, I'm still filling out the machine. But all of these rect squares would have been acceptable for a roughing cut. Do you know what I'm saying? If I were to just do one, I'd probably do this. So I'd probably do 0.5 mils at 175. So anyway, that's just a little update on that. Now, what is it that you always have a problem when you have a CNC? What is the first problem you run into? Does anybody know the answer to that?
What to do with all the chips? No.
Oh God, Thank you. That's probably, yeah, you're right. That probably is, I should said the second one. The second one is, I only need a few more inches. You know what I mean? It's always, the bed is always just a little too small. So now I have to think about how I want to approach. First of all, I got to get good on this one, make sure I understand it and use it well. But so there's two paths. One, you can start using this one to make parts for your next one. Otherwise, you can upgrade this guy, or you can upgrade this guy by making the parts on the machine. Or if you got the money, honey, they got the tool. You know, so you can decide which way you want to go on that. But anyway, this.
Hey, they still have the Haas at the makerspace, right? You could.
Yeah, well, I don't want to go over there, and I don't want to learn it. It's too much machine for me. I'm not there. What I do. So right now, what is it? You know, what do I have into this guy? See if I can get to him. You can see him there sitting on this guy right here. What do I have in him? The base cost about $180 to $200. I can't remember. This new spindle and this drive probably was another $150. So this is about $350. So I think for beginning setup that cuts aluminum, and my bed, because this guy is bigger than the original, is about 7¼ by 10½. Okay, so that's just under a page of paper. But anyway, that's where I am right now. So okay, now,
chassis.
yeah. Now I wanted to go back to Mike's thing and show him. Let's see. So this is what I was talking about. Well, am I still? No, I'm not presenting, am I? Give me a second.
No.
So do you have recirculating ball screws on the thing?
Not on this one, no.
No. Yeah.
No. Yeah, but you can. It's amazing if you want to put in about $1,000. They really do have some really nice machines out there.
Yep.
Okay, so this is Mike. This is what I was talking about.
Mm-hmm.
Okay, and yeah, and this is where you can get the download for. I think it's Saline, but I might be saying that wrong. They have this. They call it Logic, and the last version of Logic 1 was 1.240, which is probably what you need. And that looks like, let's see if I can find it. Here's an example of it with running it. They have a simulator, so you don't have to be hooked up to anything. And so here you can see that they're using four channels of the possible 8 that you could have. And, you know, you can see where they got some analyzer, and I think it's a serial analyzer. Yeah, analog, and the asynchronous serial. So you can see it's telling, up here is telling you what's actually being sent. And then
so as individual bytes, you mean, or?
Yes. Otherwise, what's coming down the serial line? So he's sending 1, 2, 3, 4, 5, 6, 8. Then he's sending a tab, and then a new line, and then a return. And I don't know if the simulator goes any further than that, because this is just a screenshot. You can't actually change anything on it. This will start the simulator. Okay, but it actually shows you the bits, and then I'm not sure what he's got on these guys, but you can see it gives you the width, the frequency, the period. It's like, if you're using 0 and 5 volts, it's like it's like having a 16, oh, well, in this case, an 8 channel oscilloscope. And you can, this in this setting box here. Oh, no, I don't know if it, anyway, this, you can set one to be the trigger. And any channel can be set to be the trigger. If this were a real, was actually something that was real instead of a screenshot, you could be able to do all of that. So anyway, there's also other alternative software packages that you can use. You just have to, do a search on Google and find out what they are. But if you don't have one of these, I would suggest go ahead and spring for the $12. And if you're really careful and do some shopping, you probably get cheaper. So, I'm just saying. So
I can see it can come in very useful for.
Yeah. Oh, it is. So, and if you look around, like I think that particular one came with DuPont leads and its own serial cord, so we didn't have it. If you go back and look at some of the other ones, they'll have little clip-on leads that you can use. Like for $14, you can get one with little clip-on leads. Let me show you that one.
So if you didn't have clip-on leads, how would you attach to circuitry?
If you had DuPont pins, you could do that.
If it's on a breadboard, you just plug it in the hole.
Yeah, right, exactly. So here's one with little clip-on little thingies you can put on, and they work. I have those. They're very fragile, though. And my experience has been that I always have a broken one, if you know what I mean. They're easy to fix, but the soldering will break, and you have to redo it. But anyway, there's like I say, there's a gazillion of those probably available. Yeah,
that's a good idea.
Yeah. Or you can buy them like this for $2.80.
Oh, for leads, yeah.
Yeah, this is the real deal. But you see, it says it's an 8 channel.
Mm-hmm. Must be higher speed. Yeah.
2, 3, 4. So here's what the guy that is. So like if you were doing this for a business, I would recommend going ahead and getting the real one. But if you're just a hobbyist, this one here. That's the way to go. All right,
yeah.
That's it.
On my oscilloscope, I sprung for a 70 megahertz one.
Yeah.
Yeah.
Well, I went with the Rango, and those are 50, I think, megahertz, or 100. I can't. It's either 50 or 100. But that's a 4-channel oscilloscope, so that's really nice too. Yeah. But anyway, that main update I wanted to show was that I am also mentioned to the group a while back that my laser had gone kaput, and I bought a brand new tube and I put it in, nothing. And I was like, oh shit. And so I went and bought a new power supply, and now it works. Now the question is that old tube bad?
Chicken or egg, huh?
Yeah, I don't know. Anyway, well, it's got a new tube in it, and it's cutting pretty good. But it's not cutting. I've also upgraded to a chiller. Put a chiller in it. I went to. I made some modifications that had bothered me on the on that laser, fix those up. So it should be, once I button it up, which I plan to do tomorrow, it'll be pretty nice, and use that. So then I got all my tools back in place after having them degrade last year. So we'll see how it goes.
Yeah, my next robot will probably be plastic, since that's the only machine I have.
Yeah. Well, I got 3D printers, and the laser cutter cuts all your acrylic. And so, the only thing I was missing was aluminum. And in theory, I had a mill to do that, but a router for us is probably better than a mill, because the bed is bigger. All right, because usually what we're making is plates, and if you are truly milling something, you can do it on a router. You just have a little bit limited Z height. You don't have what you have on a mill. Yeah.
Well, you can always turn your pieces sideways and, mill on that surface and then move it around,
Yeah.
Really, probably more useful than a mill is a lathe.
Yeah, I got a lathe, but I'm going to say it's an antique, Ted. It's an Atlas 6 that I got from my father-in-law, and yeah, it works, but it's every time you cut something on it, it's a chore.
I'm always wanting to make bushings and stuff like that.
Yes, it's good for that. It's good for that.
Pulleys, yeah.
Yeah. But I'm thinking, I'm going to try and make my Rover robot to be a 4-wheel robot, a differential, and I'm flipping around whether it should be a drive belt like Dave has. If you've ever seen his, he's got his motor mounted above his wheel shafts, and it goes down to a pulley on his wheel shaft, and then all of the wheels are tied together through a second belt. So he has one belt to the motor down to the drive, to I guess what you'd call the drive shaft, and then that drive shaft goes all the way across to all three wheels on that side. And either that, or I've got I just happen to have a lot of Vex plastic gears, and they're about this, they're the biggest one's probably about like 3 inches, maybe 2.5, 3 inches. And I'm wondering if I could just string them across, and just so have a gear drive that just went from gear to gear to gear to gear to gear. You'd have to have, I think, 5.
Wow.
So I don't know. It depends on how long you make it. The gears, if it's short, that's not a bad deal. But if it gets long, it's a big deal because you have so many gears.
Yeah.
This was another. These are, it's like a skid steer. The two sides are together.
Yeah, that's another option. Yeah.
They had a 50% off sale at the Goodwill. I guess they accumulate so much crap that nobody wants.
Yeah.
Hey, would you want it at half that price? They actually can move stuff. Anyway, this was $249, and I got it for half. So, $1.25 to find out what made the. No, it's cheap entertainment, basically. Take it apart.
Right, here's my equivalent.
Work.
Yeah.
Yeah, you got one too.
Yeah. Oh, okay.
Oh, I call that the drug dealer Mercedes. It's like a Jeep that, you can get bulletproof windows in. And
I don't know, but I will say this is, I have screwed around with this guy. And as you said, it's, each side is independent. And it's, The biggest problem with it is it goes across the grass like this, you know. It's always bouncing around. But it could be a real shortcut. And it would be a challenge to see if you could fit everything inside it.
Mm-hmm.
You know, just take the body off, see if you could put your IMU, your stuff in it, use front of it for your sensors.
New concept.
Windshield.
New
Camera
concept.
windshield.
Yeah, I mean it is. Oh, and I paid $1.91 for it.
The Goodwill RC vehicle contest.
Oh my
Yeah.
goodness.
There you go.
Yeah, yeah. I played with it on the. It's fun to play with. But it'd be cool to see.
Well, I think the requirement there, it has to be, you have to make a little figure that looks like Scott Gibson, with the Captain Kangaroo haircut, and he has to actually make it look like he's steering or something.
There we go.
Yeah. Have a scarf flying back like Snoopy.
Oh yeah, there you go. Yeah. In the wind,
Yeah. Well, I don't know. Like I said, the nice thing about that is you could quickly work out all of your software, because you basically skip over the mechanical part.
Yep.
But then again, when you start looking at it, in the past, when I've tried to use toy grade hobby things, they're very easy to hack into. They're very easy to be able to get to the steering and everything, especially the older ones. The newer ones are all surface mount and they're a little bit trickier. But the old ones, they're a dream to hijack. But the problem that you have with it is they're toys. So there's no replacement parts. When it breaks, that one's that one's gone. You know what I mean? You can't do anything with it. So, but anyway, that might be a way to do it too.
Yeah, I think that's probably going to be better than something with Ackerman steering. I think.
Oh, yeah, I agree.
Yeah.
For this, the problem with Ackerman, because I've done it for 2 years trying to do it,
Right.
is that in theory it should work really well. You should just drive up to the cone and touch it, do a little backwards like you would in your car, and zoom to the other cone. The problem is if you're past the cone and you don't know it and you got to turn around and do a search for it, it's awkward.
Yep.
It's not that it can't be done, it's just awkward. Compared to just like, I think Ted's, his just spun.
Turning in place.
Yeah.
Yeah. So that was a much better solution, or easier. Well, yeah. And I think elegant too, I mean, yeah, because I actually had my highest score on Robo Columbus has been 4 or 5 points, I can't remember, and I didn't touch a single cone. I got close to all the cones, but I didn't touch them. I did a complete loop around the circuit, going, like within 5 feet of the cone, and then off to the next one. And anyway.
So to touch it, do you put a little actuator out to touch it?
You can. That is, I believe I've seen that done, but most people just run into it.
Oh, okay.
The problem you have to watch too, though, if you flip the cone, that's a badness. So, you're not supposed to flip it or move it.
And if your robot ends up on top of the cone, then you have another problem.
Yeah. Yeah. It just sits there and dry humps the cone for the whole your whole run. That's not any good.
Let me go.
So, anyway, I'm real excited to see what we're going to come up with this year. Sounds like Scott's coming out with a new robot. and I'm expecting Ray to at least build on what he had last year. I mean,
Yeah,
Ted, you need to get back
a lot of
down here,
improvements
dude.
I can do.
Yeah, I'm gonna try to get back there.
Yeah.
Yeah.
So,
I
we'll
can
see how
double
it
the
goes.
battery voltage, and I was only going like I think the max I could do was like 9,000 encoder counts per second,
We know, Ray.
and
We know.
I was only doing like 3,000, so like a third of the speed. But
We were playing banjo while you were going. I mean, it took you forever.
PGA?
oh yeah, kind of like Pee Wee soccer. You know, the goalies are sleeping in the grass because they know that there's plenty of time to get up when the action comes their way. You know?
Yeah.
So
But except for those little horse apples, you could have been somebody, Ray. You could have
been
done
a
it.
contender.
Yeah.
All right, I gotta go. Bye.
Okay.
Yeah, I think well, it was too bad Scott fixed his, or found out what his software problem was, with he was using multiple cores and had to change had to use a semaphore instead of just a straight variable because it wasn't passed between cores or something.
Yeah.
And so he's probably found that out. But he's, the stuff that he's got, I mean, his IMU is probably more than, the cost of 3 of my robots, I mean, and that's just for the IMU itself, it's like, he's sinking some money into that thing.
Yeah, but I bet if you really look at the time and everything you've spent in yours, you've spent a lot of time in yours too.
Yeah, but hardware wise, I mean, what was that one IMU that he was looking at? It was like close to $1,000 or something.
Oh, that military quick? No, I don't. No. It wasn't $1,000.
No? Oh, I thought it was like
it was a couple hundred.
That's all? Oh, I thought it was.
I don't think it was 1,000. Yeah, and some of those things have really been hit by inflation, and I think it's because a lot of them are going over to Ukraine and Russia. So.
Oh yeah.
So. Anyway.
Stuck in the end of a missile.
Yeah. Well, I don't know. What happened to Carl? Is he dropped off or what?
Yeah, he said he had a meeting to go to or something.
Okay, so I guess he's going to end the thing. Yeah. Well, John, did you have anything you wanted to say? You've been on mute all night, and I haven't heard you. I can't hear you at all.
Still can't hear you.
Still can't hear you.
Looks like you're at the makerspace.
Yeah, we haven't been ignoring you.
Yeah.
Can't hear you.
I hear some clicks. Well, you're showing us being muted now. Before you didn't even show muted. Unclick the mute button. See if you can talk.
So, yes.
Yes, you're back.
No, I really don't have anything much, or I am looking at this one thing. So I don't know if you all want to see it. I've just found it, so let me show it briefly to you.
Okay.
Yeah.
They're always entertaining. Well, usually entertaining, John. So
yeah.
We always like to see what you've been up to.
So there's this thing.
Oh, okay. Never mind.
So there's this thing, but I just saw it, so I was reading through it. But I have no idea if they use the parts from a toy or what. I'm thinking they might have. But
so is it a weed picker?
Well, it's who knows what it is. It's just like multi-purpose, whatever platform.
It's like it's got an arm in the front.
Right, it has an arm. It has this real ping sensors wrap around. It looks like it has a bath on the back end. And
Got a
this
laundry
back
basket, but
pulls
it
the back or
doesn't
something.
look like it's doing any washing.
Hey, John, can you grab that link and put it in the chat?
Yeah, I'll grab the link. Because, it's a interesting thing. I just went across and I was looking at it going, what is this? But
Well, go to the 2 more images. Let's see what those are. Now, up in the above, it says 2 more images. Okay, well, anyway, go there. They show a schematic.
so it's
It looks like 6 ping sensors, an Omega board, feeding a Raspberry Pi,
it looks
the
like
screen, 4 motors.
it has a little bit of everything in it. It's like
What are those? Are those motor controller boards? What are those up there? Go back up to the schematic. No, I don't know what those are.
I have no clue other than it has RC receiver though.
Yeah.
S-arm server board. As I said, it looks like it has a little bit of everything in it.
Yeah. Well, there might be some ideas in
It
there.
will do house cleaning supposedly.
Yeah.
Grocery shopping.
Yeah. If you happen to scatter your groceries across your living room, it'll pick it up for you.
Take it to the grocery store.
So if you need something to pick up from the floor, it'll seemingly do that.
Ah,
There you go.
it's a nice arm. Yeah.
Robot that cleans up after itself.
Does it poop out batteries?
That's probably, I think that's underneath the back section.
Yeah, that's probably what it has. 2 parts to it.
Yeah, that's a nice camera. It looks like.
Let's see. Okay, this is more of. So there's a picture of. Okay, it supposedly does outdoor cleaning too.
Picking up individual leaves. Wow.
Pick up leaves. Yep. So if you need to pick up your leaves in the yard, this is the well be it. Yeah, just more of the same. Okay.
I'd like to make one that an agricultural one that seeks out and identifies certain weeds and has either 2 scissor blades or a rotary blade one to cut the weed out.
Well, you hear about them, similar projects. Some of them are using pickers, and some of them are using selective pesticides and stuff like that.
Herbicides, yeah.
Herbicides, yeah.
Yeah.
So, John, did you put the link in yet?
Will do. Where are we at?
Yeah, I like that oversized tank chassis.
There it is.
Oversized what?
Tank chassis. It's built on a tank chassis.
Yeah.
Yeah. I don't know where they put the batteries. It must be in the back, though.
Yeah. I like that.
Receiver, driver. Okay, just a 12. Okay, 12 volt is what they're using. So same with you need to get the C rating batteries.
Yeah. 2 S3s, 3 S's, or whatever.
I don't know why you'd need high C ratings.
Oh, it's only using an ultrasonic sensor? Did a pretty good job of picking it up.
No, he's driving it around with it. It's not autonomous.
Oh, it's not autonomous. Okay.
No, he's but it does look like he's got his. It looks like he's using a separate USB supply for his Raspberry Pi.
Probably.
Get a power bank. And I ran into some fire ants, and I didn't know what had happened, and they got all over me. Ugh.
So yeah,
Okay.
I don't know if there anything
A lot of
else.
3D printed parts.
Yeah.
That's fine.
So here's a remote control wheelchair if you want to do that. A wheelchair controller.
Yeah.
Oh, it does have a cam.
That one is the remote control wheelchair one. That's the one where you put your grandma in it and take her where you want to go.
Yeah.
Okay. Well, listen, I think I'm about out of here.
Okay.
So
But
anyway,
so that's why I have. So,
yeah,
I
let's
like
hope
it.
we can- yeah. Thanks, John. That was interesting.
Yep.
Okay. Bye, guys.
Okay. Good night.
We'll see you. Thanks.
I guess I'm going to call it a night too. But I went down to see the bats down in Austin, so I just got back today.
Oh, really?
So yeah, it was nice. The bats were out there. They're coming out a little bit earlier though because they're having to go further because it's dry and hot down there too.
Oh,
But,
not many bugs flying about. Is that?
Not nearby. They have done a very good job of getting rid of the mosquitoes nearby. So they're going further. But
Wow.
anyway, so I'm pretty warm bush from the weekend.
Yeah.
So y'all take care until later.
Okay. We'll see you.